Hello guys. Am I audible? Can you tell me in the chat? We'll wait for a couple of minutes. Please invite your friends. There are some guys joining in a couple of minutes. So we'll start in a couple of minutes. Okay. Hi guys, can you tell me how was your day today? How was your day today, guys? Can tell me. Did you have classes today? Today is Saturday. Today is Friday, right? Okay, you had class. So, do you like to go to classes or you like to play games? Gamer. You guys can tell me how was your day today? It's good? It's bad? Or it's just normal? Okay, what games you play? I also play games. I play Valorant. So guys, can you guess what today's topic will be? Reading books. Oh my god. Do you guys can guess what's today's topic gonna be? It's about DSA only, but something inside that only. Today pretty interesting things are coming up. You can invite your friends to join it. Data structures algorithm, yeah, that is the whole bootcamp is about. But today I'm going to teach you a topic within it because it's a huge like syllabus in itself. Yesterday I cannot, but now I can. Okay, no problem. We'll give you the recordings. It will be available in short while. You can see that. Did you guys make your LinkedIn account? I've told you to make a LinkedIn account. I will give you a task today. Stefan, like let me begin the class, then we'll be giving you the attendance link. Don't worry, we'll be giving you. And there is an interesting part coming to that. I will tell you in a bit. Okay, in 1 minute we'll start. Ask your friends to join now. Let's see how many you can get. Hit the like button. There's a love button here also. Okay. Ask your friends to join. Post it in your group and hit the like button. Type in comment. Are you ready for the session? Type in the chat. Are you ready? Tell me. Share this in your group, please. Share this link in your groups. They will definitely benefit from it. We'll just begin. Okay, you guys are ready now? Okay, cool. So this is the second day of the bootcamp, cracking the code, data structures and algorithm. This is the whole bootcamp is about. Now I'm going to reveal you the topic, right? So today's topic is searching algorithms, right? This is how, like, if you think like searching as a problem, it's like when you have a problem, searching is half of the problem and other half is doing with the search results, right? Now for you, you might be searching for a internship, you might be searching for a job, you might be searching for a good lab partner, you might be searching for a girlfriend or boyfriend, you might be searching for a good course good mentor to teach you DSA, right? So don't worry about that, your search has ended here. So searching is a problem, right? So it's always been a problem in coding also. So that's what we're going to learn. What are the searching algorithms that you can use to search in any data structure or in any source of data, right? So let's begin. Okay, before that, like, this is the trivia and this is the interesting part I was talking about. So let's see, there's something we need to look up to, right? So do you know how much Microsoft pays to a fresher? Do you know that? So it's here, right, in front of you, right? So you can read it like that. I can explain you what are the components and how much they are running, right? So this guy is BTech from NIT. He is a 0 years freshers, and date of offer and all these things are there. But the thing you have to look for when you are going for a job is your base salary, right? So base salary is something that you will be getting in hand. So they're giving you 15 lakhs of base salary. Then there's stocks is something that you can that has value, that which values keep changing, right? You can sell the stocks and earn money. It's not like a real cash that goes into your bank account. So that's stocks. Then there is signing bonus. Signing bonus is your joining bonus. The first year you will get it. They're giving you 5 lakhs joining bonus. What's your performance bonus? Performance bonus is based on your performance. You will get performance bonus is 1.5 lakhs. So it's like you can see 15 plus 6.93 plus signing bonus 5 lakhs, then performance bonus 1.5 lakhs, and relocation it's 4.5 lakhs, 4.95 lakhs. So it's total 33 lakhs you can earn by getting into Microsoft, right? So that's how much they're paying in and getting. You can just learn DSA and get into such a job, because this guy is also a fresher. When you graduate, you will also be a fresher. So what do you think? Like, this is great, right? There's something you need to look up to. This is what your target should be, right? So what do you think? This is a very good offer or not? Type boom in the chat if you think it is. Okay, yeah. These are we're going to learn. Okay, so cool. So you got it, right? This is what you need to look up to, and I'm going to prepare you for that. It's just the beginning, so I'm going to give you a hint, and I will give you like idea how to learn DSA and crack job offers if you stick with us till the end. Okay, so today's topic is, as I mentioned, searching algorithms. So linear search is the very basic search, right? So suppose you have list of items, you have list of books in library, and you have to search a book with a name, right? It can be like you are reading novels, then it can be Tale of Two Cities by Charles Dickens. You start, how will start finding that? First you will go to the author section. Maybe the book names are not arranged alphabetically, so you have to start from the very beginning and start searching one by one. So you'll go to the first book and check, this is the book, no it's not, then you will move to the next one. You will basically swipe across, like from left to right, to search the book. That is your linear search, right? So I will let's get into code. So Lead Code Playground will give you this online ID. So we'll add the headers. Right, now what we'll do, how to declare an array. I have taught you yesterday, right? So you can declare an array like this. Now you have to search an element, right? Let me make a function, say linear search. So this is my array, and I will need the size as well, right? Here n is equal to size of array and size of int. If you have attended the earlier bootcamp, you might have known this. Otherwise, who are coming new, this is your array declaration. This is how you declare an array. This is how you get its size, and this is how you declare a function. This is the return type of the linear search function. Why I have written int? Can anyone tell me in the chat what I'm going to return here? So I will be iterating over this array, right? And I will be okay, this linear search, this is your array part only, but there is something we need to search for, right? We are searching for a value in the array. So okay, let me name it search value, right? So what I will do here, if array of I is equal to search value, it will return me what? The index, right? If I don't find it, then it will return me, what do you think it should return? It should return -1. That means we couldn't find that element. Now what I have to do, I just have to add print statement, then I have to call this linear search function with the array, with the size, and with the search value. So what do you want to search? Let's search for 2, right? So what do you think the answer should be? Can you tell me? Write it in the chat. Let me write the indexes here. So what should come here? Can you guess the output? You can write in the chat. Okay, let's try running it. It's coming to be 1. Do you know why is it coming to be 1? Because 2 is at the second index, right? An array begins with a 0 index, so it's coming 0, 1, 2, 3, so it's coming to be second index. Now if we search for say 1, let's search for 1, it's coming to be third index, right? On the third index there is 1. Then what about if we search for say 7? 7 is not here, right? So what do you think it should return? It is returning -1. So how is it working, right? So we have passed on the array, we have passed on the value, it's iterating on each of the values, right? We have initialized the index from I equal to 0 because array always starts with index 0. Then we are checking if I is less than n or not. N is here 4, right? N is coming to be 4 here. You can see there are 4 elements here. So if it's the case, we are matching it against the search value. So search value we are checking, search value is 7, so it's not. Then we are again incrementing the I, and again we are checking it against 7, so it's not. 2 is again not matched to 7. Then again we are incrementing I to 4. Again we are checking is 4 is equal to 7. No. Then again 1 we are checking it's not. And finally we haven't got any satisfactory results. We will return -1 from here. But if we have written 4 here, it would have landed here and returned the index 2 from this function. So our output would be 2 in that case. So did you understand what I told you? You can write in the chat if you have any doubts. Otherwise let's move on, because there is something interesting coming up. Okay, so this was whole about your linear search, right? Can you tell me the complexity of this algorithm? Can you tell me the complexity of this algorithm in the chat? You can write in the chat what should be its complexity. Time complexity. Time complexity is something like how much time is going to take as an input of n, right? So you can see if my input is n, because it doesn't matter on the search value, it matter on the search space, right? So search space is basically number of elements you have to check. So I have to check for the n elements only, right? Because we have to search for n elements. So our time complexity becomes big O of n. So this is the time complexity of a linear search algorithm, right? Now let's move on. Okay, so before you proceed, let me tell you, like, this is the second day of the bootcamp, right? And today we're learning searching algorithms. Now we also have an interesting program for you guys. It's known as the campus ambassador programs. If you're interested in being a leader, and like, if you want free resources and if you want goodies from us and be a part of our team, so you can join us as a campus ambassadors in your camp. Your roles and responsibilities will be like organizing boot camps, organizing some events offline or online, and sharing the resources and all this. Like, you will get certificates at the end, you will get goodies, and you will basically learning the leadership skills. And yeah, that's it. So now if you're interested, I will tell you like how to apply for that role. Now let's talk about your attendance. Like, if you know, this is a 5 days boot camp, and whoever attending the boot camp will be giving them certificates. So for that, I'm giving you a attendance form, right? First of all, let's see what's in the attendance form, then I will share it with you. So day 2 attendance form, cracking the code, data structure and algorithm, July 21. Put your name here, put your email here, phone number here, WhatsApp number if you are interested to be updated, if you want to be part of the community, college name, NA if graduated, NA if you are not into college yet, year, you have to enter the year here, you have to put your branch here, and this is where you have to put if you are interested for the campus ambassador programs, right? So you have to fill it and mark submit. I am sharing the attendance link here. Please go ahead and mark your attendance. I'm giving you 1 minute. If you want to fill it, then let's continue. I've shared the attendance link. If you want to mark your attendance, go ahead and fill it. Have you done it? Have you filled it? Okay, let's continue. So before you begin, like, you might be knowing who am I have given my introduction yesterday only, but for the guys who are new here, I'm going to tell you about me. So I'm Tajril Ali, and this is my LinkedIn profile. I want to show you my LinkedIn profile. So I did my graduation from IIT ISM Dhanbad, and I am like, I have been working as an engineer in Uran.com for 1.5 years. Now I'm working as a backend engineer at CRED, right? So this is how your LinkedIn profile's gonna be if you try making a profile. So for you guys, I'm giving you a task today, right? I think you might have made your LinkedIn profile. Have you? Otherwise not, then you can please go ahead and make this LinkedIn profile. And like, I want to make you a post. When you can open it in your app also. There's a mobile app available. There's a post button. Like, this is how it's similar to how you do a post in your Facebook or Instagram. So you just have to write like, today I attended Skill Pulse Bootcamp and things I have learned. You can put things I have learned today. You can write about what are the things you have learned. You have learned about linear search, you have learned about some problems and extra, right? Now what you have to do, one thing very importantly you have to do, you have to tag skill pulse here, right? You have to tag skill pulse here, the one with the brain, right? Let me zoom a bit. So this you have to tag and you have to hit post, right? So so whoever does it, whoever giving this extra effort, will be sharing them some free resources. So we will be sharing them some resources, right? So what kind of resources, let me show you. So we have top DSA problems that is curated from the best mentors. So these are the problems for each topic wise. We have for array, binary, dynamic programming, graph, interval, linked list, matrix, string, tree and heap. If you want these free resources, then you have to do this activity. Then another one we have, and these are the top IT companies that you can apply to. You don't have to go search somewhere or ask your friend where can I apply. So this two list I'm going to share, and this is not the end, where there are very more. You just have to like do the small thing, right? And we'll be giving you these free resources. Okay, LinkedIn profile, let me share my LinkedIn profile here. So did you understand like what task I have given to you? So again I'm repeating, like go to LinkedIn, tap on the post, make a post like this, tag skill pulse. You have to put a @ sign so that you will get tag skill pulse and hit submit, right? And whosoever are tagging us will be giving them free resources, as I have shown you. We have top IT companies list, and we have like top DSA problems. Okay, and there are many more that will be coming up in the further sessions of the bootcamp. So without any delay, let's continue. So yeah, another thing I forgot to tell you, we have a LinkedIn group as well. You can start joining that. So this is the Telegram group. Here you will be getting updates about all the events that were taking place. So whoever is coming through YouTube only, like they can join this group. Otherwise, if you are already in part of the WhatsApp groups, then it's good only, right? So yeah, so that's all the thing I have to tell you. So let's continue, right? So this is the interesting part of the searching algorithm, binary search, right? Have you ever heard of binary search? Like, do you know what is it? What kind of search is it? Is it better than linear search? What do you think? You can write in the chat. Have you heard of binary search? And what comes to your mind when I say binary, right? What do you mean by binary? You can write in the chat. Okay. So search, you are already aware. Search means to look for. What binary means? Two, right? It's called binary because it means two, right? What do you mean by two? Because we have a whole search space, the number of elements we have to search for. We're gonna divide it into two parts and look for one of the parts, right? Again we're gonna divide that into two parts, and again we'll look into that part. But how are you gonna do that? We are going to see that in a while, right? So let's say I've given you the linear search example, right? You have set of books in a library, list of books arranged in a row in a library, and how you are going to search them. You are going to search them one by one, but it's not efficient, right? But when it comes to a dictionary, right? When it comes to a dictionary, you can search it very efficiently. You can search it very fast. Do you know the reason why you can search it very efficiently? It's because it's sorted, right? It's sorted in alphabetical order, right? So if I say this is the page of a dictionary. So we have a dictionary, right? So let's this is our dictionary, and let's say each dictionary will be having one word, right? Each page there will be only one word, right? So let's say first one is apple. I'll be writing your ABC letters, A B C, cat. Then what do you have? Dog. Then what do you have? Let's say donkey, right? Then what do we have? We have say mango, and something very at the end. Say let's put it what do you call sparrow. Then get a good name. Okay, let's name it P, right? Okay, so this is our dictionary, how it looks like. This is how it looks like, right? Now what I'm going to do, I'm giving them indexes, right? This is a array actually. So this is the zeroth phase, this is the first phase, this is the second phase, this is the third phase, and this is the fourth phase, this is the fifth phase, and this is the sixth phase, right? Now how are you going to search that, right? You have to search for say cat, right? You have to search for cat, search cat in this, right? So how you are going to look at it, right? So what you can do, you can check it intervals, right? You can check, say I will not start from the first page, I will start from the second page and check, oh it's a ball. Then what you can do, you can say no, let me just skip pages and move to the 4-5 pages back. You can see, oh it's donkey, so my search cat is before this donkey, before this D, right? So I can search here again. Then again it's dog, but again it's like a dog, cat would come before it, right? So again you will search here. So when you're searching here, you will eventually get to cat. But it's not very efficient, even if you save some time, right? It's not very efficient. So again, if you have searched it linearly, then it would be more efficient because you will be getting in cat in 3 steps. But what about donkey? If you start with say ball, right, and you have to search for donkey, right? You have to search for donkey. Then what you can skip some pages and you will reach dog. But again you see donkey is greater than dog. So you will again move some 2 pages. Then again you will say mango is greater than donkey. Then again you will come to 2 pages. So this is how, like, it's like random only, right? It's not you are using the sorted dictionary optimally. So how can you do it, right? So what I can suggest here, you have to search for cat, right? You have to search for cat. What you can do, you can go to the middle of the dictionary, right? You can go to the middle of the dictionary and search for the element there, right? You will find dog, right? So dog is greater than cat, right? So dog is so your search value is smaller than dog, so you have to move to the left, right? So what we will do now we are very clear that let me write it like this. We are very clear it's not on the right part of it, right? It's not on the right part of it, but it's on the left, because since cat is less than dog and this part is sorted, so cat is also less than donkey, it's also less than mango, it's also less than P. So our search keyword is on the left of this, right? So what again you will do, we'll say now we'll search at the middle of this part, right? This is now a new search space for us. Now again we'll land here. Again we'll see ki cat is greater than what do you call ball, right? So you will say this is not here. So our search space is not at this part, right? So what I can say, I can easily say it's not on ball or left of the ball, right? Let me pick this one. Okay, now what you can do, you will move your bar to here only, and finally you will search cat here, right? So this is how it's gonna look like, right? Did you understand this part, how you are searching it? Okay, so let me tell you like let me write the pseudo algorithm wise. So first of all, we will be having two variables. One is start equal to 0 and one is end equal to 0, right? Now what we will do, we'll search for while start is less than equal to end, we'll be keep searching here, right? So we'll be keep searching here. We'll first calculate the mid will be start plus end by 2, right? What we'll do now, we'll check if we'll be having an array. So let me write here. So this is my binary search function, and we'll be having a array, right? And we'll be having a search value, right? Okay, let me name it key and let me name it ARR, right? So if ARR of mid is equal to key, then what we can say, we can say this is our index, right? This is the required index because we have found it. But what if the case, if array of mid is less than key, then we have to move to the right. Like you can see, if it's less than key, like in this case, like key is greater than the array of mid, then we have to move to the right. So if we have to move to the right, what we have to do, we have to move the start, right? We have to move the start, and how it's going to move, like it's going to move start to the mid plus 1, right? We'll again do a diagram so it will be more clear. And else is the case where array of mid is greater than the key, right? Or you can also be explicit and write it like this: else if array of mid is greater than the key. In this case, we have to move end to the mid minus 1, right? And finally if we don't find it, then we have to return minus 1. So this is our code going to be look like, right? So let me clear this all, and let me explain you how it's going to work here, right? So let's say we have S. So S was here, and we have let me change the color. So let's say we have S, and let's say we have E. So S means start, and E means your end. We have first calculated the mid. So how mid is going to be calculated? Mid is going to be S plus E by 2, right? What is S? S is 0, and this is 6 divided by 2 is equal to 3, right? 6 divided by 2 is 3. So our mid will be here. Now let me name it fully so it would be more clear. So this is our start and this is our end. This is how we have initialized them. We have initialized start to 0, and this end, my bad, it should be initialized to 6, right? And what we'll do, we'll calculate the mid here. So first mid is coming to be 3, so I put mid here only. Now we are checking if array of mid is dog equal to cat. No, it's not, right? So if not the case, then we can see dog is actually greater than cat, right? So it's this the case now. So when we have mid this case, so we'll be calculating end equal to mid minus 1. So now my end has become 3 minus 1, that is equal to 2. Now my end has come here, right? And we have ignored this part, right? Now again we'll calculate mid, because this is a while for loop. So while for loop keeps running till till this condition is being satisfied. So we have end is equal to 2 and start is equal to 0. So 0 is less than equal to end only. So this will be continued, right? Again what we'll do, again we'll calculate mid is equal to s plus e by 2, that is 0 plus 3 by 2, and it will comes around 3 by 2 is 1.5, which will round off to 1, right? So our mid will now go here, right? Our mid will go here now. So again we'll check, is ball is equal to cat. It's not equal to cat, it's actually greater than cat, sorry, it's actually less than cat. So this is the case now. Now in this case what we'll do, we'll move start to the mid plus 1, that is mid is our 1 plus 1 is 2, right? So now our start has moved to 2, right? Now on the third condition we'll be again calculating mid is equal to start plus s plus e by 2, that is start plus n by 2, that is 2 plus 2 divided by 2, and it is coming to be 2 only. So our mid would land here, and you can see at this step also start is less than equal to end. We will be continuing and finally we'll be reaching mid here. Now this condition we'll be checking, like cat is equal to cat, yes it is, so we'll be returning this mid. So mid is our desired index. So this is how we are going to run binary search. Did you understand this? You can write in the chat. So it might be complicated, but yeah, this is how it's going to be worked like. So let me summarize. Like we are given the full search space, we are taking the middle element and comparing, is it greater than, less than, or equal to the search element. If it's equal to the search element, then it's well and good. Otherwise we'll say this is greater than the search element, so this right part we don't have to look into because it's less than this element. So again we'll look in this part, again we'll get to the middle element and see if it's less than if it's equal to the required element. No, it's not, but it's less than the required element. So we'll again move to the right. Now this only left, right? So this is how you will get you will do binary search, right? So this is my for loop, right? Sorry, this is my binary search code. So let's write it down, let's code it down, right? Okay, we have already opened one. Let's write here only. Let's name it binary search, right? I'll be getting an array here, I'll be getting an n here, and we'll be getting the search value here, right? What we will do, we'll be having start initialize to 0, we'll be having end, which is initialized to n minus 1. We'll be writing here, let me write it down. So it will be, let me copy this and write it here, right? So this is what we are going to write. Okay, so what we are going to do, we'll say start is less than equal to end, then we are going to calculate the mid is basically start plus n divided by 2, and we are comparing if array of mid is equal to search value, right? We'll be returning this mid index. Otherwise you can check if array of mid is less than search value. In this case what we have to do, we have to set the start to mid plus 1, else you can write else if, or you can write else, it doesn't matter because all the cases are covered only. Else means what's remaining, right? So in this case you have to write end is equal to mid minus 1, right? And finally what we have to do, we have to return minus 1 here if we are not able to search here anything, right? Now let me write binary search here. So in this case let me do one thing also. let me write both binary and linear search. We have the linear search function as well. So let's search for 4. Let me run code. Okay, I have to put a handle here. And right, so it's coming to 2 only, like second index. So 4 is located in the second index, right? So let me write it again. So it's coming to be second index only. Now what about if I search for 3? Okay, there's some mistake here, I guess. Array of mid. Okay, so first thing first, I forgot to tell you, the important condition of a binary search is that this needs to be sorted, right? That's why we are able to reject the right and left part. So this is not sorted, right? So we are getting a wrong answer here, even if 3 is present, but we are getting a wrong answer here. So for binary search, it's very important that you sort this array first, right? We have written the insertion sort earlier, but there's a easy function that you can use from STL. What is STL? It's standard template library that you get when you include these files, right? So when you use this sort function, it sorts the array, right? But the index will be now different. So let me write it like this only. This won't be applicable now because you will be confused, right? So let me sort this here itself. So 1, 2, 3 and 4. This array needs to be sorted. Now if I search here, it's giving me index 2 where 3 is located, right? Now if I search for 1, it will give me index 0, correct? If I search for 4, it will give me index 3, right? Again, if I search for say index 6, it will, sorry, for value 6, it will give me -1 because it's not located in the binary search, not located in the array. So binary search is not able to locate it. So am I clear till now? You can write in the chat. In the middle of the array, the target value. Yeah, correct, Stephen. Yeah. So can you tell me the time complexity now? This is a very tricky question. Can you tell me the time complexity here? Can you guess? So let me make it easier, right? Make it easier for you to understand. Say we have a let me say, okay. Now let's say we have 16 elements at start. Let's say we have 16 elements at start. Let me delete this. So all these 16 elements, you can arrange them in a square, right? You can arrange them in a square. Now what I'm going to do, you can think of it as a paper, right? You can think of it as a paper. Now what I'm going to do, this is my step 1. I'm going to fold it halfway every time, right? I'm going to fold it halfway every time. Now what I'm going to do, I'm taking this paper, I'm folding it in half, right? When I say folding it in half, you can think of it like this. I'm folding it from this part to this part. Now it has become, this part would have been gone now, right? Now again, what you have to do, again you have to fold it in half, right? So again I will copy this and fold it in half, right? So again these 2 elements are gone. Now again what I'm doing, again I'm taking these 4 elements and folding them in half, right? So now again I'm getting here. So and finally we'll be doing our final fold, and we'll reach eventually to 1 square only, right? So can you tell me how many steps it takes me? So you can say this is my first step, first fold, this is my second step, this is my third step, and this is my fourth step, right? After fourth step you get to a single element, right? So it takes only 4 steps to reach it. So you can think of it like it has taken only 4 steps even if there are 16 squares, right? What about linear search? So linear search for sorted array would have taken you have to search for every one, because you will go one by one, right? You will go one by one and search it. So it will take you 16 steps to search in a linear search. It is the maximum possible because it may be at the end, right? But for binary search it is always going to be 4 steps only. Can you see a relation between this, right? You can easily see it's like 4 into 4 is equal to 16, which can also be written as 4 square, right? Now if I have to write 4 in terms of 16, so what it would be, so I have to write it like this: log 2 of 16, which is equal to 4, right? So this is my time complexity. So because n is here 16, n is the number of elements, so your time complexity will be O of log n, right? Let me write it like a big N so it is more clear. So the time complexity will be O of log n, right? Now what about mathematically? Like there are some nerds here I know who wants a mathematical explanation as well. So so we have n first, right? So what we are doing it, we are dividing it by 2, right? Again what we are doing it, again we are dividing it by 2, right? So we are going on dividing it, right? So we are going on dividing it. Let me write it like this. So we are going on dividing it by 2 and on and on and on, right? Now what we are doing, we are saying we are dividing it by 2 to the power k times, right? We have divided it by 2 to the power k times, right? And let's say we have divided it by k times. Let me write here k times, right? Now what we are doing here, I am saying ki this is finally become 1, right? It has become 1. So what I can do here, I can write it like this: n is equal to 2 to the power k, right? We can write it like this. Now what we can do, we can take log of 2n on both sides, right? So if we taken log of 2 of n, so it will become log of 2 to the power k, right? So now what it has become log of 2 of n. It has become k will be coming outside and it will become log of 2 of 2, right? 2 in the subscript actually. So it's finally, I'm omitting the logs. Okay, let me write it now. So it becomes k, and we know log of 2 of 2 is 1, right? So this is 1. So finally we can say our k is equal to log of 2 of n, right? So this is how you are going to calculate the time complexity, right? Okay, so so this can be also written as 4 square is also written as 2 to the power 4, right? 2 to the power 4, and that's how you are going to get so you can see, you can represent it 2 to the power 4, and 4 is our the required time complexity. You can also see it from here that we have got it till here in 4 steps only. So that is how you are going to calculate the time complexity. Are you clear? Are you clear? You can write in the chat. Okay, let's move on. So let's take a lead code problem, right? Now say you are given a number and you have to find the square root of that number, and you don't have to worry about the decimal part, right? So what I'm telling you, so this is a question here. So you are given a number, say you are given a number, say n equal to 4. You have to find the square root of n. What is the square root of n? Do you know? It's 2, right? And what is the, if n is equal to 8, what is the square root of 8? Square root of 8 we don't know, right? So let me write it like this. So it will give me square root of 8 is coming to be 2.28. You can use a calculator. What is n is equal to square root of, say, 16? It's square root of 4. It's coming square root of 16 is coming to be 4, right? This is because when you multiply 2 into 2, it gives me 4. When I multiply 4 into 4, it gives me 16. When I multiply 2.28, it gives me a number close to 8, right? Now what I want, now my function needs to return the nearest integer part only. You don't have to worry about the decimal part. You just have to return the integer part only. So in this case 2 will be returned, in this case also 4 will be returned. And let me take a number like 64. Sorry, let's take another easy number like 49. The square root of 49 is, what do you call it, 7, right? So now we just have to, given a number, we just have to return the square root of that number. So basically we have to implement a square root function. Now how are we going to do this, right? So let's assume, say we have to calculate the square root of a number, say let's take 16, right? 16 we have to calculate. Now what we can do, we can take a number line. This is a number line, say, and this is your 0th value, and this is your 16th value, right? Now what we can do, this I can initialize it with start, and I can initialize this with end, right? Now what we can do, we'll following our binary search algorithm, right? Let me copy this part. So it's visible, right? So first what we're going to do, we're going to calculate our mid, right? So mid is start plus n by 10. So here my start is 0 and end is 16, right? So my mid is going to be 0 plus 16 divided by 2, right? How much is going to be? It's coming to be 4, right? So mid is now around 4. Sorry, what I'm doing, it's 8, my bad. It's coming to be 8, right? So mid is now 8. So let me write 8 here. 8 will be around here only. Now what I'm going to check, instead of this, I'm going to check if say array of mid, it's not going to be array of mid, it's going to be mid only. So let me do the modifications here, because mid is now a number, right? So what I'm going to check, if mid into mid, if square of mid is equal to key, right? If that's not the case, if that's the case, then we'll return mid. If that's not the case, we can write it like this: mid into mid is less than key, right? Otherwise we have to write it like this: mid into mid is greater than key, then we'll be decrementing it by mid minus 1, right? But you can see we have got mid here, and we'll checking 8 into 8 is equal to how much? It's 64, right? Which is greater than 16, because we have n equal to 16 that we have to search for, n square root we have to search for. So in this case what we'll do, we'll move n here, that is 8 minus 1, right? So our start is still 0. We'll have moved our n to 8 minus 1. 8 minus 1 is how much? It's 7, right? And now we'll again calculate mid. So mid is 0 plus 8, sorry, 0 plus 7 divided by 2, which is coming to be how much? So 7 divided by 2 is 3.5. 3.5 rounds to the nearest integer, which is coming to be 3, right? So now my mid is here, 3, right? Now you can see we'll be getting this, right? We'll be getting 3 into 3 is equal to 9, which is less than 16, right? So again we couldn't find the number, so we got it key, it's on the right of the mid, right? So we'll move start here. So we'll move start here. That becomes start is now becomes 4, right? How it becomes 4? Because start is equal to mid plus 1. Mid is 3 plus 1, which is become 4, and end remains the same. So end is 7, and again what I'm writing here, end is 7, and again we're calculating mid. Now 4 plus 7, so 4 plus 7 divided by 2, how much is going to be give me? So 7 plus 4 is 11. 11 divided by 2 is 5.5. 5.5 rounds up to be 5, right? So again we'll check 5 into 5 is equal to 25. It's greater than 16, right? So again we have to move our end. So start remains the same, it remains at 4. We move our end to, now we move our end to 5 minus 1, right? So it becomes 4. Now our mid becomes how much? It's start plus n by 4, that is 4 plus 4 by 2, it becomes 4 only. Now what we'll get, 4 into 4 is equal to 16, right? Which is equal to 16. So in this case we'll return our mid. But there is a catch here, right? This is going to be solved. This is going to give us the correct answer if it's a perfect square. But in the problem it's written here, it cannot be a perfect square also, right? It can be any number from 0 to 2 to the power 31. That's like a huge number, so it can be any number. In this case, like you can see, for it we are getting answer 2, but in this case what we'll get, so let's not get confused. Let's first try to implement this, and let's see what's the problem in it. I request you guys to tell me like what change we need to make for this to work, and what's the problem that's going to be. Can you tell me? So I'm writing like this, right? So I have initialize start with 0 and with x. Now what we are doing, we are basically making this while for loop, right? We'll be putting this down. Now what we are doing, we are checking int mid is equal to start plus end, and we have again mid into mid. Mid into mid is multiplication symbol, right? If you're not aware. So again we don't need to add curly braces every time. So again we are checking here, mid into mid is less than key, okay, and again else if mid into mid is greater than key, right? So now finally what will return, we'll return here mid, we'll return here -1, but let's see, and key is x, right? Okay, let me write it key, so that's how we are going to understand. So I have written it like key, right? Now let's try to run. Okay, I have to put a semicolon at the end of the statements. It's just something you have to follow in C++. What do you think? How many test cases is going to be passed out of 2? So this is passing. As I mentioned, it's working. It's going to work for this perfect square numbers. Let's say, let me put here 16. Let's say it will work or not for 16. No, right? It's not going to work for you because it's giving me -1. Sorry, what happened? Okay, so for 16 it's coming, but for 8 is giving me -1, right? So it's working for perfect square numbers, but it's not working for like non-perfect squares numbers, right? So what we have to do, let me tell you what you have to do. When it's not a perfect square number, you have to get to the nearest integer, right? So let's take this example again. Let's take this number line again. Or let me do one thing, let me clear this out. Let me clear this out. Let me redraw a line. Right. Now n is 8, right? So we'll be start here, and we'll be starting end here. Now we'll be having start will be at 0 and end will be at 8. Now we'll be calculating mid. So mid comes around, how much? Mid comes around to be 0 plus 8 by 2. 8 by 2 it comes around to be 4, right? Now 4 will be here only. Now when I check 4 into 4 is equal to 16, which is greater than 8, I will move my end to the right here. So end is now at 3. Now start is equal to 0, end is now at 3. Now my mid will become 3 divided by 2, that is equal to 1, right? Now again we'll check 1 into 1, that is equal to 1, but it's less than 8, right? But 1 can be a possible answer, right? 1 can be a possible answer because we need a number that is giving square less than 8, right? Which square is less than or equal to 8, right? So what modification we have to do, we have to add an answer here, right? And this answer would be initialized to anything. You can initialize it to -1. But what we are going to do, we are saying ki if it's less than equal to key, in that case we'll be saying we have got our answer. We'll be saying answer is equal to mid, and we don't need this part because this is now included. So we have merged the above two statements. Can you see? We have merged this one and this one, and saying ki like even if we get a number lesser, which square is lesser than this number, we will be taking this as an answer, and finally we will be returning answer here. So you can see because of this our answer is recorded as 1. But again we are saying ki it's not the desired value, we'll be still keep searching, right? So again what we'll do, so end was here, mid was like around 1, mid was around 1, right? Let me write 2 here as well. Okay, so we'll say even if we got an answer here, answer was earlier -1, we'll still keep searching, right? So when you keep searching, we'll be doing again start is equal to mid plus 1. Now start is here, right? So again start is at 2 and end is at 3. So now my mid becomes 2 plus 3 by 2, that is 5.5, which becomes, sorry, it becomes 2.5, which is 2 only, right? So now my mid comes here only. So now mid is 2 only. Now again I will check 2 into 2 is equal to 4, which is less than equal to 8, right? Which is less than equal to 8. Again I will say my answer can be updated here, because every time it's coming to be less than equal to 8, we're saying answer is equal to 2, right? Now what we're doing, we're checking again what we're doing, we're increasing ki our answer could be on the right. So again we're increasing start to the right of mid, right? So again it will land here. So now start is also 3, end is also 3. Now my mid becomes 3 plus 3 divided by 2, that is 3, right? So mid also comes here. But when I see 3 into 3 is 9, which is greater than 8, right? So in this case what we'll do, we'll be moving our end to the left of this, right? So in this case start less than equal to end no longer valids, no longer holds, so it will break out of the loop, and finally we will return answer from here. So answer in this case is 2, right? So this is the only change we have to do here. So what we can do, we can initialize answer. You can put it as -1. You can do what you can do, you can make it like this, right? And put this statement. When you're putting multiple statement, you just have to put it like this, right? And users have to initialize answer like this only. Did you understand this part? You can write in the chat. Did you understand this part? Do I need to repeat? Did you understand this? So we initialize answer is equal to mid and start is equal to mid plus 1, right? And finally we are returning answer from here. Now let me run. So it's passing all the test cases, right? Again, there is something I need to show you, but it's something you will learn along the way. So let's say there is something called as integer overflow, right? Integer overflow happens when for this integer, right? For this integer there is a fixed capacity to it, and this is the max value of integer, 2 to the power 31 minus 1. Do you know why it is the max value? Like, you can go and read about it. And there is another data integer type that is long. Let me try to submit and see what's going wrong, right? Okay, it's saying me integer overflow, right? This number is very huge. It cannot be fitted. So it's coming around 1.5 to the power 10 to the power 18, right? It's visible here, right? 10 to the power e to the power 18. But what is my max value of this integer? This is the max value of integer, which is coming to the 2 into 10 to the power 9. So when you multiply 2 into 10 to the power 9, 2 into 2 to the power 10 to the power 9, it becomes 10 to the power 18, which cannot be fitted into integer, right? So what I can do here, I can do a in place conversion. When I say 1ll, it becomes, this integer becomes a long int, and this also becomes a long int then, and it's comparing with the key, right? And it's comparing with an integer value, and this all becomes long int. So now you can see, like, this part is becoming long int. Now let me try to submit if it's going to work or not. Okay, again we are doing here the same thing, right? Again we have to put it here also. I missed this part. Or there's another simple way. I will also show you that. I've shown you the complex way first. So this is now submitted, right? Another way could be, users say this is not int, it's a long int, and long int has a capacity of 2 into 10 to the power 18, as you have seen, right? So now this has automatically become like, this part has already become 10 to the power 18 only, and since this part left hand side is 10 to the power 18, there would be this will also be elevated from integer to long, and this will also become 10 to the power 18. So this only change you can also do, and the answer will be the same only, right? It's getting accepted. So yeah, so that's how you implement a my square root function. So are you clear on this? You can write in the chat. Okay, you understand. Okay, very good. Okay, very good. So yeah, so that was about binary search. It's a very good algorithm. You can I'm giving you a problem link. You can try solving this. Sorry, you can search it like this. Let me give you the question. Search, insert, position, lead code. Okay, so this is a problem like where you have to search where 5 should be inserted, right? It should be inserted at the second index, right? Means basically this is the same question as searching a value in an array. Like, you have to search 2. If you cannot search 2, you can say it should be at the 1th index only, because you will eventually land here. Say, you can say like you have to search 5, it will give you second index only. Like, it's saying ki you have to find that value. If you are not able to find that value, you can tell where it should be inserted, so the array remains sorted. Like for the 2, it should be inserted at the first index. So that means it is like 1 3 5 6. When I inserted in the first index, it becomes 1 2 3 5 6, right? This list becomes sorted, right? You know the indexes. This is 0 1 2 and 3. If I inserted in the first index, these elements I have to shift to the right, and this is how my array becomes. So you can try attempting this problem. I am sharing the link. And what I can suggest, you can go to lead code and search some of the problems there, right? You can make an account there and search for the easy problems. You can sort them by easy, medium, hard. These all problems you can sort. You can also search them from binary search, right? You can try solving them. That way you will be having more command to it, right? And yeah, I think that's it. Like, do you have any doubts? You can ask right now. Am I clear? Did you enjoy this session? Tell me. Like, do you have any feedback? Like, is there anything I'm going too fast, I'm going too slow, or do I need to cover more problems? You can tell me in the chat. Otherwise, I'm waiting for 1 minute, and where I have left. Okay, thank you. So that's it for the session today. Hope you enjoyed this session. You can write in the chat if you liked it. So yeah, bye bye, good night.